polynomials that have a higher degree, meaning larger than quadratic. Right, quadratic is that x squared. We're going to factor out some higher degree polynomials today, and we're going to factor out by grouping. So we're going to start with this example. We'll go through this example just to see where we're even getting a higher degree polynomial from and how we can factor them out. So we have a packaging company and they sell two kinds of boxes. This tall box here, box A, and then this shorter box B. They're going to come out with a new box, box C, and it's going to have a volume that's the same as these two combined. Okay. We only know one dimension of the new box. We only know that its width here is x. So we want to figure out its length and its height. How can I represent the volume of the two boxes combined? Let's start with box A. How can I find the volume of box A?
Multiply it all out.
Multiply what?
The width and the height and this
Yeah, if I'm finding the volume, our traditional formula for volume is length times width times height. So for box A, what would I multiply? So in your notebook, just multiply that out. This is a great practice of multiplying binomials and monomials. If I multiply x times 3x plus 7, what do I get? Who wants to share what they got when they multiply? Ibrahim, go. 3x cubed plus 7x squared. Now you can do that in stages. X times x is the same as x squared. So if you wanted to multiply it like this, how would you multiply that? What does that look like? Yeah, it looks like the distributive property, which we started at the beginning of the unit. We multiplied a monomial times a polynomial. Right, so we would have 3x cubed plus 7x squared. Now, what would we get for the volume of box B? What would we multiply? Times? What's your question? So again, if we're finding the volume and we're multiplying the length times the width times the height, I have the length of h, the width of x plus 3, and the height of x plus 3. How can I multiply that? Where would you begin if you had to multiply something like that?
x plus 3 squared.
Okay, so you want to do this first. If you want to use that strategy that we learned last week, you could, or you could distribute or FOIL it out. If I did that, I would have x squared plus 6x plus 9. But I still would need to multiply it by what? X. And what would you get if I multiplied that through? X to the third plus 6x squared plus 9x. Okay. And again, I know it's been a little while since the beginning of our unit when we were just multiplying a monomial through. This brings back some stuff from past units too. When I multiply and I have the same base, what do I do with the exponent? Right, so it all starts to come together here. So our first box, we had 3x cubed plus 7x squared. And here we have x cubed plus 6x squared plus 9x. How would I put them together? So this is one of the expressions, and this is the other one. And I want to find the total of them. So what do I want to do now? I want to add them together, but I have to be really careful when I add these expressions together. What do I add together? Only the like terms. Who can remind me, what does it mean to be a like term?
Same variable, same exponent.
Same variable and same exponent. Who can give me an example of something that I could combine here? Patrick, what do you got?
Nothing.
Nothing. Okay, Laura, what do you got? What do you think?
6x squared and 7x.
Yeah, if I'm combining these two expressions, I can combine the 6x squared with the 7x squared. And how many x squared would I have? Alright, so 13x squared. Good, so I've added that and that. What else could I add? Sarah, what could I add?
3x cubed plus x cubed.
And how many x cubed would I have?
4.
Plus 4x cubed. Now what? Yeah, I still have a 9x. Still have a 9x, not yet. So if I needed to represent the total volume of the taller box and the total volume of the smaller box, I would come up with 4x cubed plus 13x squared plus 9x. But now, what do I need to figure out? If I know that the total volume of these two together is 4x cubed plus 13x squared plus 9x, I also know that that's going to be the volume of this box.
You could find out the length.
Hold on, I'm going to come back to you in a second, Patrick. So if the volume of this new box that they're going to use is this expression, 4x cubed plus 13x squared plus 9x, how can I find the side lengths? What do I know?
That's the volume.
That's the volume. Good. Okay. And how did I get the volume? How would I get the volume of that box? I would multiply the length times the width times the height. Do I know any of those values?
You know that.
Do I know any of them? What one was given? I know one of them, so I have x times the width times the height. So if I needed to backtrack, right, and kind of undo that calculation for volume, how would you figure out the width and the height?
You would just do the.
What thing?
You could just factor.
Okay, what would you factor?
You would times the 9 and 4.
But can I do that yet? If 4x cubed, 4x cubed plus 13x squared plus 9x is the result of the length times the width times the height. You already told me I knew one of them. Right? I knew that, let's say the length was x. So now I need to find these two values. How can I undo that calculation to find them?
Oh, you could do.
I can factor out an x,
Yeah.
right? If I factored out an x from this expression, what would I have? What would I have?
Or
Just an
4x
4x squared
plus 13x.
So now I know that if this is the length, what does this represent?
That's basically.
What would that represent? If the x is the length, then what does this whole thing represent? The width times the height. Yeah, I heard somebody say it. The width times the height. So what can I do with this expression? If I know that I multiplied two things to get that, what would you do to figure out what those two things were? Think again, if I multiplied two expressions to result in that, how would you go backwards?
Divide by 2.
Unfoil.
I would unfoil it. Or what do we call that? What have we been doing for 2 weeks?
I don't remember.
Factoring. You would factor it. Factoring is the opposite of multiplying, right? If I multiplied them, we did that first, and then the second thing we did was we factored. So we can factor this out and figure out what two things. Quiet down. What two things did I multiply to give me that? Are they monomials? Is it possible to multiply a monomial by a monomial and get a quadratic trinomial? No. What did I multiply by? What did I multiply to get a quadratic trinomial? binomials. So I can factor this. This is what we've been working on. We're dealing right now with a quadratic trinomial that has a coefficient greater than 1. How would I factor that?
4 times.
Okay, I can multiply 9 times 4 and get 36. Good. Now what? Factors of 36 that add up to 13. What are they?
9
9 and 4. What do I do with them? This is the big one because a lot of you are missing this. What do I do with the 9 and the 4? Okay, but what do I do with the 9, the positive 9, and the positive 4?
Substitute. Replace them with the 13.
I'm going to rewrite the trinomial.
Plus 9 plus
A lot of you are still forgetting to rewrite. You're just saying here, I had a lot of this. That's what a lot of you did. You figured the 2x times the 2x would have given you the 4x squared, and you found factors that added up and had to be 9 and 4, so you left it. The problem is, if you multiplied this through, it would not have given you the trinomial you started with. So that is not correct. We need to rewrite this as a 4-term polynomial. Once I have this, what am I doing now?
trying to
What's it called?
Oh, factor.
The other one.
Unfoil.
Yeah, now you're going to unfoil. That's the result of foiling through. I took some term. I took some term and I multiplied it by the binomial. That's here. And then I took a second term and I multiplied it by the same binomial. That's here. That's why the result, this arrow set here and this arrow set here, that is why your parentheses will be the same. Because I essentially multiplied by the same binomial. So finding the greatest common factor, if I multiplied one thing by this binomial, and I ended up with 4x squared plus 9x, what is the one thing I multiplied through? An x. And what am I left with? 4x plus 9. Now I already know that if I multiply 2 times here, I also multiply by the same binomial. This has to be a 4x plus 9. So what can I factor out? Just a positive 1. Which means, yes, my length is x, but what's my width and what's my height?
x plus 1.
Width could be x plus 1,
And your height is 4x
and then the height would have to be 4x plus 9. So that's a lot together. But what did we do? We're going to go through slower with the grouping. We took a higher degree polynomial, right? We actually figured out a way to factor something that's cubic. And that's what we're going to focus on today. This is really just the intro question. Yeah. Don't worry. In my opinion, it's just my opinion. Don't quote me on it. This is a little bit more straightforward. That's a complex problem. That one that you just saw.
Yeah.
So let's take a look here. Now we have our higher degree polynomial. We're not dealing right now with a quadratic. We're not dealing with a quadratic, nor are we dealing with a trinomial. So we're going to learn today a way to factor a higher degree, typically cubic, polynomial with 4 terms. Okay. If we are going to factor out this higher degree polynomial, we are going to factor out the greatest common factor of every group. Okay, so notice what I did. I broke them up into 2 parts. Again, this still is the result of unfoiling. Same concept here. If I broke them up into groups, my goal, and you can write this. This is a great example to have in your notebook. That's supposed to be red. There we go. Your goal is to find a common binomial factor. So if I needed to take out the greatest common factor from 3n cubed minus 12n squared, what would that be? Okay, so we could definitely take out an n. How many n's could we factor out? Okay, so it's 3n. Any exponent? A 2. They both share an answer. And if you needed at any point in time to re-break this out, that's 3n cubed. And then this would be negative 4 times 3n squared. They share the 3n squared. What's left?
You have an n
I have an n
and minus 4.
and a negative 4. This. What if I factored greatest common factor here? So what do you think my answer would be? If I said what would I factor out? What are the factors?
3n squared plus 2 and then n minus 4.
So here you're actually still finding two binomials. What's the difference between the other things we factored? Yeah, one of the binomials here is squared. We haven't been dealing with that yet, but now you can see how you could factor a higher degree. When you get to algebra 2, you will factor larger things and different things. But right now, we kind of use what we know about reverse foiling to factor out something cubic, for term but cubic. And really, for those of you that need that visual, this would have been the result of the F and the O of FOIL, and this would have been the result of the L and the I. So, I multiplied some term here, that was the F and the O, and then some other term here, that would have been the I and the L. By finding the greatest common factor of those first two terms, I'm finding this, and what is left. And then I can backtrack. The only thing I could have taken out that would have left me with the n minus 4 would be the positive 2, if you needed the visual. If the polynomial was written like that, would I still be able to factor it the same way? Try it. Humor me. Try it the way we just did. Would you still be able to factor out if it was written that? What's the difference between the way it's written now? There's some stuff moved around. Just try it. See if you can factor it. Still end up with the same answer. We already know the answer from the previous slide, so we could maybe have a discussion about what happened.
I know there needs to be an there. So let's just say that that's all I'm writing. So I'll just put 3 and to the second plus 2.
Does anyone want to walk me through how you grouped this and factored? This is now we factor by grouping. What groups did you do?
Wait a second.
Same process that we just did on the previous slide.
Do you factor out the things? You factor out the terms? Oh, so factor out from the first.
So do that.
Wait, yeah, I guess I have a I got.
For those of you that are finishing up with the factoring, could we have done it this way and still gotten the same answer as before?
I did get.
Yes.
But I got 2 different.
So take a look at the top here with the original problem, right? If we grouped this out, we could have factored out a 3n squared. We'd be left with n minus 4. And then a 2. So the way we factor this top one, if you were to multiply everything through, that first binomial that you multiplied, that's not would have been like that. You would multiply the 3n squared by everything else, and then the 2. That's why it turned out this way. For the second one, when we're trying to see if we could do it this way, David, what's the greatest common factor of these first two terms?
N.
Just an n. And what am I left with?
3n squared
3n to the second
plus 2.
So I know that if I take out the greatest common factor, the other parentheses would also need to be 3n squared plus 2. But if you forget that, just take a look at the two terms. the greatest common factor would be what? A negative 4. A negative 4. And then I'd be left with a 3n squared plus a 2. So if I had to rewrite this one, the first binomial would have been the n minus 4, and it would have distributed to the 3n squared plus 2. Can I change the order of multiplication from this to this?
Yeah.
Sure. Yeah. 3 times 2 is the same as 2 times 3. And that's really what it would look like. Questions about this example? Anything getting you hung up about this example? So here's the thing. It's tough to identify sometimes what way you would factor. But if you look at this problem, we're going to do one in a second, sorry. If you take a look at this example, when we began factoring about halfway through the unit, we started by just factoring out a monomial, like the greatest common factor. Remember, we took every term, we broke it out, we circled what was common. Take a look at these 4 terms. Could you do that?
Let me see, where is it?
For the 3n to the third plus 2n minus 12n squared minus 8, is there something besides 1 that you could factor out from all 4 terms? No. That would be the indication that something else would factor, that it would most likely in this situation be factoring by grouping. If I had something like something like that. I could factor out the greatest common factor, that they all share 3, they all share an x. And I could pull out the monomial and leave the rest. This situation that we have today, you can't. If you're looking at any type of polynomial and you cannot take out something besides the number 1, which we don't need to really do that, then there would be another method. And most likely right now, if you're dealing with a higher degree, in Algebra 1, we pretty much stop at this for higher degree. So if you see as you're going through that you can't take out a greatest common factor, which would be the first thing you look for, then it would most definitely be this strategy. Our higher degree factoring is relatively limited in Algebra 1. You're going to try one before we transition to some practice. 8x cubed plus 14x squared plus 20x plus 35. The same way that we did the other examples. How could you factor by grouping? Factor out just because with the exponent. All right. So if we see this 4-term polynomial, is there a common factor between all 4 terms?
No.
No. That would be where your factor by grouping radar would come into play. And how could we factor this by grouping? Remember, this being the result of FOILing, what could we do?
Well, we can break it up into 2 groups.
We could break it up into 2 groups. Good. And now what?
And then factor from each group.
Factor each group. So what can I factor out of that first group? David.
So that's the second
2x squared. What's left?
4x
4x
plus 7.
plus 7. I could always check if I need to.
Ow.
For the second group, what's common between them? A 5. And what would be left?
4x. 7.
Now I can check here my 2 parentheses. I am looking for my parentheses to be the same, which they are. Which means the 2 binomials that I multiplied to give me this 4-term polynomial were what?
2x squared plus 5.
2x squared plus 5, and I multiplied that by what? Perfect. Questions? All right. So let me pause the video here before we start what we're going to do.